So I decided to look in the manual under the brake section to see if I could figure out whether or not it's a possibility that my brakes are hanging and that's what's causing it to slow down. So under the brake section of the manual, there's this general description of how the brakes work, and it basically explains that it's a compensating brake cylinder system. It's got two master cylinders, one for each wheel, but then there's a pipe that actually connects the two of them together. And the idea would be that if one brake pack was wearing more than the other one, that the cylinders would actually be able to compensate. The independent cylinders would be able to compensate for the difference in wear, so that when you press both brakes simultaneously, you still get an even braking force on both sides. But then I noticed this right here. So this describes something called the inching control, and what it basically does is it's a valve on the transmission that responds to pressure from the braking system. And when it senses pressure from the braking system, it will actually cause a valve in the transmission to move to allow control hydraulic fluid that's supposed to be controlling whether or not the unit moves forward or backward and how fast it moves, to actually bypass where it's supposed to go and go into the tank. So essentially what it does is when you step on the brakes, it actually causes the hydraulic motor in the transmission to slow down and stop. So if you've got the forward reverse lever on the column, say you've got that in forward drive and you're driving along and you slam on the brakes or you step on the brakes hard, the system will automatically slow the machine down or stop the machine. So there's no danger of the hydraulic transmission trying to run against the applied brakes. But because there may be a time when you want the transmission to continue to give power to one wheel, say independent braking, say you don't have the two brake pedals latched together and you want to make a really tight turn and you want to step on the left brake, but you want that right wheel to continue to drive. And it's for that reason that there's actually an ingenious system that will be able to tell when it should be responding to brake pressure and when it shouldn't. Here's a general diagram showing the piping of the braking system. So we've got the two independent master cylinders for the left and right brake. We've got the reservoir feeds fluid through two lines to both master cylinders. Each master cylinder has one pipe that outputs to one brake pack, either the left or the right. But then we have this line right here, which actually connects the two cylinders together. It kind of ties them together. So the one thing I don't understand that's not shown here is there's nothing indicating exactly where that pressure signal from this braking system is actually getting to the inching valve. So I suspect that actually happens internally. So I suspect that actually is happening internally here in the transmission. So here's a diagram that explains the operation of the inching valve. So this is your brake pedal right here. This is your master cylinder. This right here, D, is an isolation valve. And this is electrically controlled. And I'll get to that in a moment. But the idea is that when brake pressure is applied and pressure builds in this line, if the isolation valve is open, that will allow this brake pressure to go and actuate this piston right here. E gets pushed against this spring, and that will open an orifice and allow hydraulic control pressure that's supposed to be managing the output of this hydraulic pump to actually decrease, and the output of the hydraulic pump will decrease greatly and basically slow down the hydraulic motor in the transmission. So whether or not pressing on the brakes has any effect on controlling the transmission is dependent on whether this isolation valve is open or closed. What they did is they've got an ingenious circuit here using relays that basically will tell this valve to open only if both brake pedals are depressed. So if you have the brake pedals unlatched so that they're not locked together and you step on just one brake pedal or the other, this valve will not be energized. So the other interesting thing about this valve is that when this valve has 12 volts applied to it, that's when it's actually closed and isolating the brake pressure from the inching valve. And what happens is there's two switches located on the brake pedals. They also actuate the brake lights, but they are wired with the relays in a way so that both switches have to be actuated, and that will allow the relays to open and de-energize this solenoid valve. Once this valve loses its 12 volts, that's when it allows the fluid to pass and have an effect on the inching valve. And the reason why that's interesting to me is because that means that if something's wrong in this circuit, a blown fuse, bad relay, wiring, whatever, and 12 volts is not getting to this valve is going to be open and allow this brake fluid pressure to get in here and mess with this inching valve. And if we have a problem with one or both of these master cylinders sticking, you could see where that pressure is going to just be allowed to go right through this valve and affect the operation of the inching valve. And those of you who have been watching my channel, watching me work on this thing, you know that there was a mess underneath that control panel there. The fuse panel and all of that, the mice getting in there, it was a nightmare. So for starters, I think I want to locate this inching valve and see whether or not it's got 12 volts going to it. So looking down, here's the dashboard. This area right here between this like bulkhead thing and the dashboard, right down in there you can actually see the two master cylinders. You can see there's 3 lines. One of those lines just goes up to the reservoir for the brake fluid. Another one of those lines actually just loops over and connects the two of these together. See, this is right here, this one just connects the two together. And then these 2 lines, this one and the one opposite it on the other cylinder, those both go down to the braking system, the clutch packs. But they don't go directly there, or one of them doesn't. I'm now laying underneath the machine and looking straight up toward the underside of the floor. And what I'm trying to get you guys a good look at is this block right here. This little box right there. And then right next to it there, that's the actual solenoid. So that solenoid is actuating a valve or something inside that block right there. So moving out towards the left, there are the 2 hard brake lines right there side by side. They continue back to the rear of the machine and they transition into these flex lines right there at that point. See, there's the hard line going in. It's going to be hard to focus, but and then there's 2 flex lines that go into these big brake packs on both sides of the axle. So one of the lines from one of those master cylinders just pretty much goes right through this area right here and passes right on over to the packs. The other one is connected to this box and solenoid, which is the isolation valve. And it looks to me like, by design, there appears to be a trap door right directly above this. That trap door appears to be right in this area right here. So I've got to get this rubber mat lifted out of the way again. Oh, by no small miracle, I got these two screws out. And on that side, I got one of them out and the other one was already snapped from the last time I had to take this apart. When I had to take this rubber mat out of here to get that whole dashboard assembly opened up. But unfortunately, all that did was expose another problem. This panel that I want to open up is held in with 4 Torx head screws that are really badly rusted in there. This one, I can get the driver to engage it, but I don't think I'm going to be able to put enough force on there to break it free without it stripping out or snapping the bolt. More than likely just stripping out the head. This one is so full of garbage that I can't even get the bit in there. So not looking too good. And now it occurs to me, maybe I'm jumping the gun here and I don't even need to get to that valve just yet. Rather than get to the valve to unplug the plug and check for 12 volts there, maybe I should just figure out where that wiring goes up into the dashboard and fuse panel and work the problem that way, because it's got to go through some relays up there. So in the manual, they give you this wiring diagram for how that system works with the switches on the independent brakes. These are the brake lights, and this is the isolation valve in question right there. And they actually give you 2 diagrams to show you the difference of what actually happens when you have the brake pedals latched together and the brake pedals unlatched. And in both of these situations, the brakes are being applied. So latched would be both pedals are being depressed, both switches are being actuated. Unlatched would be one or the other, but not both of the brake pedals are being depressed and one switch is being activated. Green is ground, or the return path. So one side of the solenoid valve is grounded. So as soon as we have 12 volts on this side of the valve, it's being actuated. But as I said earlier, by design, before the brakes are pressed, 12 volts is being fed to this valve. This isolation valve should be energized when you're driving. Power for the valve comes through 2 relays. This relay here, EM2, and this relay here, EM1. They're actually in series. EF1 over here, this relay, is strictly for the brake lights. So it's independent of these 2 relays. These are the inching relays. So in this example over here, they're showing you that when both brake pedals are depressed, these relays are going to not allow the 12 volts to get to the isolation valve. The isolation valve will be de-energized and will allow that brake pressure to affect the operation of the inching valve. Well, this is interesting. Here's the compartment that houses all of the relays and the fuses. And what I just discovered is these fuses don't appear to be in the right positions. For instance, there are 2 30 amp fuses right next to each other right here in this lower bank of fuses. According to the diagram, the top bank of fuses is A1 through 10 and the bottom bank is B1 through 10. So this should be B1 over here. This should be A1. So A1 should be a 10 amp fuse, and according to the list here, A1 is a 5 amp fuse for the glow plugs. But let's say this was flipped around for some reason. Let's say that this was A1 over here and this was A10. Well, A1 is brake lights, 7.5 amps. So either this one, or this one should be A1, a 7.5 amp fuse. And instead we've got empty, 10, empty, 15. So this is B1 and this is B10. I was able to figure this out because there were 2 15 amp fuses in B9 and B10, which according to the diagram are for interior light radio, which is for an enclosed cab, which I don't have, and B10 is for the rear fog lights, which I also don't have. So it turns out those two 15 amp fuses actually belonged in these two spots here, which were the front and rear working lights. So by putting these 15 amps into this position, now my front and rear lights work, which leaves B1, 2, 3, and 4. 3 and 4 have 30 amp fuses in them. And 3 and 4 are for the cigar lighter and the face level fan, and then B4 is for road lights, dip, and main beam. So again, I think that's for a completely different machine. So I don't know why these fuses are even in here. Same thing with this one. B2 is the right-hand side lights, and B1, which is empty, is the left-hand side lights. Those don't exist on this machine either. So maybe they were just using these to store these extra fuses. The funny thing is, these 30 amps, there's only one 30 amp used in this whole machine. That's an A9 for the heater fan, which again doesn't exist on this machine. But there is a 30 amp in its position right there. Oh, so I forgot to mention this. This mess of wiring hanging down off the roof is exactly how I got the machine. And I figured that it had to do with the turn signals and the brake lights and, you know, the rear work light and the horn, and I didn't mind that those items didn't work. But it appears now like maybe I need to pay this more attention, because even though I don't care about it, even if I don't care about it working, that wiring could be shorting things out, blowing fuses down here that are critical to other circuits. For example, that whole circuit I just showed you with the inching valve relays and everything works in conjunction with the brake light switch relay, which is powered by whatever powers the brake lights. So a short in that wiring harness going to the brake lights, one or both of them, could be taking out a fuse down here and causing all kinds of problems. I just climbed up there on top of that roof and took a look at the wiring on top there, and it's horrible. It's got a lot of areas where the insulation looks like maybe mice chewed it. Nearest I can figure is maybe at some point somebody had a tarp over this machine, and the mice probably nested underneath the tarp and just chewed the hell out of the wiring on the roof. The amazing thing is that some of the functions actually still work. If I put the road flashes on, the two in the front flash and one in the back flashes, and when I use the directionals, the relay goes really fast on one side because it's not having as much current drawn through it, because one of those lights in the back doesn't work. There's a horn right up there that has never worked since I've had it, but when you press the horn button on the dashboard, I can hear a relay clicking. And I did check the wiring going to the horn is connected. I don't know if it's, you know, got an issue somewhere else or not. But it turns out maybe I don't have to worry about the wiring going to the solenoid at all, because I happen to step on the brake pedal with the key on. You can actually hear the relay clicking underneath this panel. You can hear the relay back there clicking, and I can hear the relay itself, the solenoid. You can hear the solenoid actuating. Notice this hangs up. See? But I somehow doubt that that was my problem. I don't think this brake was just hanging a little bit and causing the issue. So it's been a few weeks since that video you just watched was shot, and the Backhoe is running great. So I lost some video clips there at the end, some editing errors there. I inadvertently lost some footage, so let me just give you an update.
Last thing I did was I made sure that all of those fuse holders were clean. There was some corrosion in there, and I put all the fuses in what appeared to be the proper locations for where they're supposed to be. Then I noticed that it almost seemed like I don't remember hearing that isolation valve for the inching valve. I don't remember that clicking on and off when you would hit the foot pedal, the brake pedal. And it seemed like it was doing that now. So just for the heck of it, I drove it around and I noticed it wasn't slowing down. It wasn't losing power. So then I shifted it into high and drove around with it like that. I've been using the machine off and on for the past few weeks, and I'm not seeing any more issues with it not driving. I honestly don't know exactly what I ended up doing to fix the problem, or if it just decided to heal itself. I kind of doubt that. There's a couple of possibilities here. My first thought was it could very well have been that the old fluid that was in there and the filters that were in there were causing some sort of a situation where things were kind of gummed up and not being able to move. Maybe there were some valves, pressure relief valves or something like that, that were sticking or something along those lines. So the other thing I was thinking about was I was wondering whether or not it had something to do with these brakes hanging up. So for like the first 2 or 3 weeks that I was driving the machine around and using it, I didn't touch the brakes at all. I was actually scared to. Not only that, but wasn't so much scared to, but what I wanted to do was I wanted to satisfy myself that it was working perfectly fine. And then I figured then if I started using the brakes and all of a sudden the problem returned, I would be like, aha, now that's my common denominator. Something to do with using the brakes has caused the problem to return. Or the problem could just return on its own, I guess, but you get my point, or I hope you do. So recently I tried using the brakes, and the brakes work, and it doesn't seem to be causing a problem. The other thing is, in earlier videos I had shown that there was a lot of electrical wiring damage underneath that dashboard from mice, and I had to go in there and I had to take care of a lot of stuff regarding I had to replace I think I replaced 1 or 2 of the relays and 1 or 2 of the relay sockets because they were so badly corroded. And I redid a lot of the wiring just to make sure that I didn't have any bare... There was a lot of wiring that the insulation had been eaten by mice, and I didn't want bare conductors that were going to be corroding or exposed and could short out. I'm wondering whether or not some of those fuses that were in the wrong position that have to do with the lights on the top there, maybe there's a sneak circuit somewhere, and those actually also have to do with supplying voltage to that whole weird dual relay setup there for that isolation valve or that inching valve to work. But for the time being, I'm quite happy with the fact that I can use my machine again. That being said, there's still a couple of things going on here that I'm not sure about. Well, maybe like 3 issues. And one of them, I'm not even sure if it's an issue. But I've got that noise that I talked about. That strange whirring noise. That's actually a pretty good impression of it. It's kind of hard to hear over the engine noise. What I'm going to do is I'm going to start the tractor up again. You'll hear the noise. I'm going to do the thing where I step on the pedals again, because when I step on the pedals the noise goes away, which is another weird thing, right? And then the other thing I'm going to do is I'm going to shut the tractor off while it's making the noise, and you will hear the noise really loudly because the engine will die and that noise will die a little bit later.
Alright, by putting the camera back here, it'll be further away from the engine noise, so you should be able to hear it better. And then you can actually watch me step on the brake. Noise doesn't go away.
So interesting. When I have this bar in position so that both brakes actuate at the same time, stepping on the brake doesn't make the noise go away. When I go to the independent brakes, left brake makes no difference, right brake makes the noise go away. I turn the key on, I step on the brake. Sounds like that relay circuit's working the way it should. When I step on both brakes, I can hear the relay clicking. I'm sorry, I'm saying relay, I mean solenoid. The relay is clicking behind me, but the solenoid's underneath the floor. So this noise that I'm concerned about, it's been doing that since I've owned it as far as I can recall. So I just don't know if that's just normal. Another way to make the sound go away altogether is just to put it in drive. Push the forward reverse lever to forward. Neutral, reverse. So that noise is only when it's in neutral. The other thing that doesn't seem right to me is the operation of the inching valve itself. If I'm reading the manual correctly, I should be able to put it in drive, be moving forward, and without having to put it in neutral, hitting the brakes should cause the thing to come to a stop. Well, I guess it does. Okay, so I think that's working correctly. Another thing that seems odd to me is when I run the front end loader, tilting the bucket in one direction seems to put an awful lot of strain on the engine. And I mean, that bucket isn't that heavy. So let me demonstrate now. I have it at 1500 RPM. Raise the bucket. Seems normal, right? A little bit of loading. Now let me tilt the bucket down. Now watch when I tilt the bucket up. You think I've got a full load of gravel in there or something. Down. Now, I get it, sure. Obviously it takes more power to tilt the bucket back. Gravity's helping it go down. Let's try a little more power. Maybe I'm being picky. And the last possible issue I'm going to have to keep an eye on is this light right here that's not currently lit. It was very dimly lit, and it was showing, and that's the high oil temperature light. Now, according to the owner's manual, it appears they used one light that could be turned on by either high engine oil temperature or high hydraulic oil temperature, which is kind of weird. It's not lit at all now. And then the other day, I was running the backhoe quite a bit, using the backhoe, and this light came on brighter, which concerned me. But when I went to the hydraulic cooler in the front, and I put my hands on the fittings, they were hot, but not so hot that I couldn't put my hand on them. And one was significantly cooler than the other, indicating that the cooler seems to be doing its job in cooling the oil. You know, when you shut it off and you turn it to accessory, the warning light's light, like just like in a car, and then when you start it, the lights go out. It's interesting, this light doesn't come on, or any of these other lights do not come on when you have it in accessory or ignition on with the motor not running. This one's oil pressure, so that one goes out like it should, which is good. But, you know, if I end up having a problem where this temperature issue rears its head again, then I'll probably post another video working on that. Or if the mysterious problem of it not being able to drive correctly comes back on its own, we'll have to tackle that. But for right now, I'm very satisfied with the way the machine is working. I'm really liking this machine. My entire life I've had, you know, good old Yeller there, the Oliver 770, the one that many people came to this channel for originally. I still have her, but there's really something to be said for a machine that has four-wheel drive and brakes that work and safety features and good tight hydraulics, which reminds me, I gotta grease all of these freaking fittings on this thing, because this thing hasn't seen grease in a while, so I gotta stop using it till I get some good grease in there. Alright guys, so I appreciate you. Yeah. Well guys, I don't know, I'm gonna call it a wrap.